Hi, my name is Keisha Wallace, and I'm with ACEWell Scholars. Today we will be learning how to solve absolute value inequalities. So let's begin. Here are our following lesson goals. Lesson goal number 1, understanding absolute values. Lesson goal number 2, understanding inequality symbols. And finally, lesson goal number 3, solving absolute value inequalities. Let's understand what an absolute value is. Well, what is an absolute value? The absolute value is the distance a number is from zero. The absolute value symbol consists of two vertical bars. So let's say we had the absolute value of 4 and the absolute value of -4. Well, the absolute value of 4 just means how far is 4 from 0. And as we can see, 4 is 4 units from 0. The absolute value of -4, the absolute value of -4 is just saying how far is -4 from 0. And as we can see, -4 is also 4 units away from 0. So, what is the absolute value? It is the distance a number is from 0. Now, let's look at understanding symbols of equality and inequality. When we're dealing with equality, we will see the equal sign, or we could see the not equal sign. When we're dealing with inequalities, we see the less than, greater than. We could also see the less than or equal to and the greater than or equal to. So, what does less than mean? Less than means that all values less than the value we're comparing it to can be considered. Greater than means all values greater than the value we're comparing it to should be considered. Less than or equal to means all values less than, in addition to the actual value we're comparing it to, should be considered. And greater than or equal to means all values greater than, as well as the value that we're comparing it to, should be considered. Now, let's look at the rules for solving absolute value inequalities. Given an inequality in the form absolute value of x is less than a, or absolute value of x is less than or equal to a, I call this case 1. And with this specific case, the solution will always be of the form x is greater than -a and less than a. So anytime we have case 1, we'll be using the word and. And as you can see below, the graph will model the picture that we have here in our table. Let's look at case 2. Given an inequality in the form the absolute value of x is greater than a, and a is some constant, or the absolute value of x is greater than or equal to a, the solution will follow this form. Now we start by splitting the inequality into two pieces, like what we have below. We will have x is less than -a or x is greater than a. If we're dealing with a greater than or equal to sign in case 2, the solution will be as follows. X is less than or equal to -a, or x is greater than or equal to a positive a. And the graph will follow the model below. So let's start with our examples. Example 1, we have the absolute value of x plus 2 is less than 3. Well, when we're solving absolute value inequalities, it's very similar to solving absolute value equations, where before we solve, we want to get the absolute value by itself. As we can see, our absolute value is already isolated, so we can go ahead and determine our case. So, we've already made sure that the absolute value is isolated. Now, we need to determine which type of inequality we have. We have a case 1. So, the case 1 follows the and solution form. So we will set up our inequality as x is greater than -a and less than positive a. And the graph will also follow this model. So let's go ahead and set up our inequality. We notice we take the 3, which is our a, and we write it as a -3 on one side of our inequality and a positive 3 on the other side of our inequality. So our inequality reads x plus 2 is greater than negative 3 and less than positive 3. So to solve, we're going to minus 2 on all sides. Negative 3 minus 2 is going to give us a negative 5, and 3 minus 2 would give us a positive 1. So our solution is x is greater than negative 5 and less than 1. And our graph is as follows. Notice we have an open circle because we're dealing with a greater than and a less than. Because there's no equal to within this particular inequality, our circles will remain open. Let's move on to example 2. Well, when we're solving absolute value inequalities, what did we say before? We need to make sure the absolute value is isolated. And in this particular problem, it's not isolated. We have a minus 3 on the same side as the absolute value. So we need to first isolate it so we can determine what case we're working with. So we're going to add 3 to both sides. That gives us the absolute value of x minus 2 is greater than or equal to 4. Okay, so that means we have case 2. And case 2 has this solution form, where we will have x is less than or equal to negative a, or x is greater than or equal to a. The or is what we use for case 2. And our graph will follow this model. Let's finish our example. So we're going to take our expression out of the inequality and have x minus 2 is less than or equal to negative 4, which follows our solution form, or x minus 2 is greater than or equal to 4. All right, so let's solve both inequalities. We're going to add 2 on both sides. The 2's cancel out, and we're left with x is less than or equal to negative 2. Now let's look at our other inequality. We're going to add 2 on both sides, and we get x is greater than or equal to 6. And our graph can be seen below. Notice in our graph, we have closed circles. Closed circles mean that the inequality includes the number that the circle is on the number line. So again, our solution is x is less than or equal to negative 2 and x is greater than or equal to 6. My name is Keisha Wallace, and I'm with ACEWAL Scholars. Thank you so much for allowing me to teach you this lesson. For additional resources, please visit us at www.acewalscholars.org. Have fun learning!